Okay, hello. I hope you are doing well. I am Mohammad Javad Zalaghi from Robotic Knowledge channel, and in this video I'm gonna show you simulating a Rosbot in Webots by a ROS2 package. So I have created a new project to improve my ROS2 skill development and to be more realistic and having more fun with robots. I'm using a Webot simulator. So I have a word on Webots. At the meantime, I have a ROS2 package which collaborates with that word in Webots. So I will add more features to it based on my goal, and for this purpose I have created this repository in GitHub, so you can find it in my ROS2 Webots repository. So this is the word of my Rosbot, a simple word with a Rosbot. I will explain why I'm interested in Rosbot a few minutes later. And currently we have two packages in our ROS2 packages, in this repository for having a co-simulation between Webots and ROS2. The first package is named ROS2 Webots _ Rosbot, so it's obvious that I'm using Rosbot in this package. And the second package is ROS2 Webots TurtleBot. So based on the naming, it's obvious that I'm gonna use TurtleBot in the second simulation, but due to limitations of the TurtleBot, for example, it doesn't have an IMU in Webots, its definition in Webots, so I'm not gonna use any more TurtleBot, and I have mainly focused actually on this Rosbot package. So here I have provided a demo which shows how we can start the initial simulation. So I'm gonna do this in this video, and I have provided installation procedure for this package. I'm using ROS2 Iron. I have installed Webots. Also I have installed Webots ROS2 package, which is a bridge between ROS2 and Webots, which I have provided information about this bridge in my previous video. You can check that. We will provide installing using Docker later, and I have provided the steps for running our simulation, which we will also try it here right now. And here I have a roadmap for myself. I'm gonna in the next step, so in the next video probably you will see that I have visualized the robot using ROS2 with its frame, with its sensor data. The next step for me will be implementing an IMU based localization algorithm. So for example, using extended Kalman filter and etc., that localization package. I will improve the localization accuracy, and I will add SNAM. So these steps are the next somehow the next milestones for this project, but I'm gonna add more items based on the time, and I will be happy to hear from you if you are gonna try this package and do this simulation. This would be a great opportunity for us to improve both our simulation and Webots and ROS2 development at the same time. And I'm actually happy that we have this Webots ROS2 package to do this kind of simulations. So that was for the introduction part. I'm gonna launch the robot, the word that I have created. I'm sorry, I have to fix this mic here. I know it's voice collecting will be somehow downgrade when I attach it here, but because I wanna use my second hand, I have to do this. Perfect. So I have sourced ROS2 and I have sourced my package. So I have a launch file which launches my word. I wanna do it here. So ROS2 launch. My package name is ROS2 Webots _ Rosbot, and my launch file name is Rosbot _ word _ launch.py. So okay, here we have a typo Rosbot. Perfect. I have launched my word, which is inside the Webots. So let's divide the screen. So this is the Rosbot that I have placed inside this word, and you can see the visualization of LiDAR data like this. Okay. Then I wanna somehow control the robot. The first thing that I have provided in this package is a keyboard teleoperation node, which gets the character from the user and will send that character to the robot's actuators. Okay, so I have to run that node, ROS2 run ROS2 Webots _ Rosbot. The name of that node, let's see the name of all executables. Okay, we have this one, Rosbot get keyboard Rosbot get keyboard command. Okay, let's see it. Now I believe my hand will be available for actually acting as an stand for this microphone. Perfect. So as you can see, my node is waiting to get character from the keyboard. Okay, so I'm pushing the down arrow. Okay, perfect. Down arrow has been pressed and robot is moving backward. I'm pushing right now the left arrow, so the robot is turning left. Now I'm pressing somehow the right arrow, so my robot is turning right. And if I push the up arrow, my robot will move toward that object, that tree. Okay, so I'm gonna stop this teleop node, and at the same time I'm gonna stop this simulation, because this is what I have created by now. And as I mentioned, as I shown for you, the next step will be having a virtual simulation using ROS2 also for this robot, which is actually in Webots, but we wanna visualize the robot at the same time in ROS2 also. So I'm gonna stop also this word, and right now I'm gonna show you the code behind this simulation. So perfect. As you can see here, I have my package is ROS2 Webots Rosbot. I wanna explain the components of this package. I have an include folder, which is somehow for my C++ executables, header files, or libraries. I have a launch directory, which holds my Python launch files. You can remember I use this one, Rosbot word launch, and this one will execute my simulation, my word, my Webot word, which includes the robots, and also this launch file also will run the external controller of the robots inside that Webots word somehow. So it is a simple launch file, which is based on the available demos provided by Webots _ ROS2 package. So the first part is how this launch file acts. Actually, let's start with the end part. So it provides a launch description for Webots itself, its supervisory feature, and a robot driver. Actually, it's not turtle but driver, it's Rosbot driver, because I'm using name of this Rosbot, so it would be better to somehow update this naming, but not important right now. So in abstraction, so in little words, we are starting the Webot external, the Webots itself, the word inside the Webots, this default word, which is the word that I have created. I will show you. Then the robot driver, the driver for the robot will be actually executed. So this is the launch file for the word, which can be more complicated if you are going to add more elements, more robots, or more execution from other packages like SLAM or localization, which is not done yet at this package, but this one will be updated with those executions in the future. As you can see, as I mentioned, we have provided the name of robot here. We have provided URDF for the robot's components, the devices that the robot has. We will see that file. And for the word file, as I mentioned, we are using a created word inside the Webot, which with the name of word _ robotic knowledge. We have a proto folder, which includes the proto of the robot. If you are not familiar with proto, please Google proto in Webots, and you will be more familiar at that time. Somehow in summary, we are defining actually the components of a robot in a text like this, with the name of the robot name that proto. It has information about the components of the robot, for example the wheel or IMU or distance sensor, LiDAR slot, this information. Every device component on the robot somehow is defined here. It's not being used in this package, in this ROS2 package, but to have a more accessibility to the name of devices, I have placed this one here. At the beginning of the video, I asked the question if I actually considered the question. Maybe you are wondering why I'm using this Rosbot, this somehow tiny robot, but really equipped robot, because it has a lot of sensors. So you can find more information about Rosbot here, actually in this website, webots.cloud. Then we have proto for Rosbot. Okay, if you search in Google Rosbot proto, you will find access to this page. And As you can see, it's a famous robot developed for ROS2 development, for Rust-based development, and you can find information here. But I want to show the devices that this robot has. It has an accelerometer, a camera, a compass, a distance sensor. It has a gyro. It has an IMU. It has a LiDAR, and it's equipped with rangefinder from as a depth camera in top of the robot. So the robot somehow has almost every sensor that you need for performing a good simulation, a good development, and actually for improving your familiarity with different kind of sensors. So this robot is somehow amazing for me because it, as I mentioned, it has lots of sensors. The next folder is the resources folder. I have defined URDF of the robot. This URDF is somehow different with other kind of URDF that you are familiar. For example, we have one URDF for a robot, which actually in that we are going to provide information about the geometry of the robot, its links, its joints, But this URDF, which is gonna used by this simulation package, is somehow for providing how to get data from devices available, in this robot. So here we have a standard. You can define the device, for example, kind of device. Its type is going to be selected here. What is the name of that device? What should be the frame name for this device? What is the update rate of the device? What should be the name of the topic that data of this device is going to be published over, So it's somehow a URDF for setting up the naming of topics which are actually the output of the devices of the robot. So I have set this information for LiDAR of Rosbot and its IMU because I don't need directly gyro and accelerometer data. I'm actually using information of this IMU. But maybe you are wondering how I have done this work and how I have actually followed up this structure of defining this kind of URDF for ROS2 and Webots simulation. You can actually get your answer here if you check Webots and ROS2 package reference. For example, if your robot is equipped with an IMU and you wanna define a topic in ROS2 for that IMU data. There is a guide which tells you, for example, you must use a plugin, and you can, for example, set the update rate of data here, or more information. And currently, these devices are somehow supported by this package. For example, if you are using a robot which does which has a gyro without or accelerometer, but it doesn't have an IMU, so in that case you won't be able to use data of gyro or accelerometer directly. So this is another reason that behind my motivation for using Rosbot for this kind of simulation, not a Turtlebot, because Turtlebot in Webots does not have an IMU. So this is the answer for another question that I asked you during this video. So in the resources folder, I have defined URDF for my robot, and as you can remember, this URDF was being used here for launching my robot in actually its external controller. So I'm telling that please publish data of devices like what I have defined in URDF. Also, the robot name should be Rosbot underline robot in the word definition, in this actually word underline robotic knowledge Webot definition. You can check that I have defined the robot name like this. So the external controller will find the robot in that word. Okay, also you can see kind of type of controller is somehow external. So you are now familiar with the content of resource folder and this words folder, and you can remember that this word was gonna pop up when I run this launch file. And there are two more folders. The first one is this folder ROS2 Webots and ROS2. So you are wondering why the name of this package is used in this folder, because I have placed my Python executables inside this folder, and the rule is if you are using Python executables in your package, the name of the folder which includes the executables should be the name of the package. Okay, and in this folder, which, as I mentioned, I have placed my Python executables. Right now, only this executable. I have provided a driver for my robot, which has a class Rosbot Webots driver. I have defined and activated 4 motors of the robot based on the naming of the wheel motors in the proto of the robot. I have created a twist message. So I'm sorry. I have subscribed to a topic, Webots Rosbot command velocity, which I'm actually publishing twist kind data on that topic, and this is my callback. When a new data is published over this topic, please update the twist of the robot based on the twist received from the message, and this is the step function of the node. So I'm actually defining forward and angular speed of the robot based on the x value of that twist message and z value of angular velocity of the updated twice of the robot, and I'm updating 2 right and 2 left speed motors speed based on the value of the forward and angular speed. So I have simple kinematic here, and finally I'm setting the velocity of 4 motors based on the updated value of the commands for to the right and left motors. Here interesting part for me is as I mentioned, important part is name of these joints must be defined based on the proto of your robot. And for example, you can check them here. We have actually not here. Let's check this one in the proto. So F1 front left wheel joint, for example. Then have a look in the proto. Okay, we have front left wheel joint with these parameters. Okay, so this is the application of a proto file in your package. Okay, but another important question is, okay, we are getting the information of a twist from a topic, which I will cover later. How I'm gonna publish keyboard data over this topic. You are asking how Webots got the information from this node. That's a good question. So remember this executable name, Rosbot _ robot _ driver, and I have defined this Rosbot Webots driver inside. Okay, so let's turn back to the URDF, which as I mentioned enables you to customize the name of advertisement of the data from the robot. Okay, but there is a plugin, so I have provided this comment. This plugin connects robot driver node from ROS to Webots. So the type is name of the package, name of the executable, and name of the class, which includes one step function. And in that step function, you are gonna publish data to the defined motors. Okay, So here we have defined this motor based on their naming. And the point is we have a node, actually Webots underline node.robot, which provides information of the robot when for actually this robot item, for this robot object, when you have defined and created this plugin inside your actually robot's URDF. So that's the key point. And the next question is about providing twist data on this topic for the robot. You can find the answer in the Rosbot get keyboard command C++ executable a node which is developed by a C++ function. So this is the naming keyboard up node, and I have provided a get character function. I have actually, if you are wondering what is the logic behind this code, you can Google for it. But to be honest, I'm not sure about that. I only find the code and try this part of get character, and it was functional, so I'm using it. Then, as you can see, I'm publishing a twist message on that topic, which has the robot drivers, which the robot driver has subscribed to, and it's going to be done. The publishing is going to be done each 50 milliseconds. You can see the callback is when up arrow key is somehow pressed. The twist message is updated by linear value for in x direction with this value, and we have the remaining logic for 3 remain keys, and finally this updated twist message is gonna be published on this topic. So I explained this part for the word, so you are now familiar with the executables that I have in this package. And finally I'm gonna to actually review the XML file of the package with you. Name of the package, its current dependencies. I am Mohammad Jawad Zallari as the maintainer, and here we have also the CMake. It's somehow tricky to have adding. You have to update the CMake each time you are going to add a little information, a new node or a new part to your ROS2 package, because if it got some ambiguity, you won't be able to actually debug it easily. So I have here added my dependencies. I have defined the launch, word, and resource directories. Here I have created my C++ executables here. For example, this Rosbot get keyboard command. I'm here installing that C++ executables. I'm doing the same thing for my Python executables. So here I have defined my Rosbot robot driver here, and that's it. So in summary, okay, let's maybe perfect. So actually okay, so I have a ROS2 package. So this is my ROS2 package, which has actually some executables, and I'm sending data to Webots. So here I have Webots. Sorry, this is it's my first time using this actually drawing tool here. So here I have Webot. Here I have, for example, my tiny robot inside the Webots. Okay, then some acting and getting data from, you know, that world. And I have shared with you the most important part of my current beginner package. So as I mentioned, I'm gonna add the next development based on you know, this roadmap currently. I would be happy if you are interested in this package, and I would be happy if you are gonna test current available features. I'm doing my development, you know, on this development branch. So, but the main branch actually would be stable for your testing or your reference, if you are wondering and you are interested in this package. Currently it's not much complicated, but it would be soon. So thanks for watching. I am Mohammad Jawad Zallaqi from Robotic Knowledge channel, and I would be happy if you can subscribe to this channel, and you know, it's better than for subscription trying this package, and I would be happy to get your opinion. Thank you, and take care of yourself. Bye bye.